In our first unit, we're going to talk about voting theory. Now, when you think of voting, you typically think of the way that we have historically voted for things, where you choose who you want to win, and whoever gets the most votes is then the winner. And so that's one way to conduct an election or to vote, but it turns out there are other ways that we can run an election. And so in this unit, we're going to be looking at those different methods for calculating who is the winner of an election. And we're going to find that there are many different ways to vote, and we're going to look at 4 specific voting methods. But before we get into talking about the methods, we first need to get some background information and some definitions so that we have the information we need to be able to discuss the different methods. So let's start with the introduction. When we talk about the election itself, there are essential elements for every election. We need 1 candidates or choices, so who are we going to vote for? And then we need 2 voters, so who's going to do the voting? When we talk about a ballot is a form of record of a voter's choices. Now, if you did not already do this, make sure that you do print out the student notes and that you fill in the blanks as you go through the videos. If you need to pause, you need a little extra time to write, then just go ahead and hit your pause button and fill in those blanks. That way you'll have those notes to go back and reference when you are working on the assignments. So a ballot is a form of record of a voter's choices, and then a ballot may include one of 4 different things. It may have only the favorite choice. So probably most of the elections that you have worked in or dealt with in your history have been where you only choose your favorite choice. But you can also give top choices in no particular order. So say your top 2 or top 3. You can give your top choices in order of preference. So in that case, you might give your first and second choice, or your first, second, and third choice. Or you can give all of the choices in order of preference, and that's called a preference ballot. And so for our intents and purposes, we're only going to work with preference ballots. So all of the choices are going to be on the ballot, and they're going to be in order of preference from first to last. Some assumptions that we're going to make about preference ballots is that they are linear. So in other words, 2 candidates cannot be tied for a ranking. So you can't say that, oh, well, either of these can be my first. You have to give 1 candidate first, 1 second, 1 third, so forth and so on. We also are going to assume that our preference ballots are transitive. And so when I talk about transitivity, I'm talking about the transitive property, which says if a voter ranks A before B and B before C, then we will infer that the voter would rank A before C. So in other words, if they have A in first, B in second, and C in third, then we assume that A is going to be in front of C, and that B would also be in front of C. And you may be thinking, well, isn't this always true? And the answer is no. There are situations where the transitive property does not apply. For example, rock, paper, scissors. If you have ever played rock, paper, scissors, you know that rock beats scissors and scissors beats paper, but that does not mean that rock beats paper, because paper actually beats rock. So that's one example of where the transitivity or transitive property does not apply. But remember, for our intents and purposes, we're going to assume that on our ballots that the transitive property does apply. So one of the things that we're going to want to do is we want to take all of our preference ballots and combine them together into a preference schedule. And a preference schedule is simply a way to organize and summarize distinct ballot results. And in a preference schedule, you will have each column representing a distinct linear preference ballot option. So in other words, you're going to take all of the people who voted the same way or ranked the candidates in the same order, and you're going to lump them together into a single column. So at the top of the column will be the number of people who voted that way, and then you will have the ranking of the candidates underneath. Then, if you have other voters who voted differently, you would have a new column that would represent those voters, and you would have a new ranking. And again, at the top, you would place the number of voters who had that ranking. So let's look at an example. Let's say that we have the following preference ballots, and it looks like we have 10 ballots in this case. And so what we want to do is to combine them into a preference schedule by grouping together like rankings. So let's start with A, B, and C. You will notice that in our preference ballots, there are 2 ballots that ranked the candidates A, B, C. So we are going to combine them into a single column on our preference schedule with a ranking of A, B, C, and the number 2 at the top to indicate that 2 voters ranked the candidates in that order. Next, we move on. We have BCA. Again, there were 2 voters that ranked them in the order BCA. So there's a 2 at the top of that column. And we repeat this pattern. There's 1 ACB, 4 ballots or 4 voters ranked them CAB, and then you have 1 that ranked it BAC. So we can take these 10 ballots and combine them into a single preference schedule where we are indicating how many voters ranked the candidates in each ranking. So let's look at another example. We have an election is held to choose the replacement for a retiring city official. The candidates are attorney, barber, chef, and doctor. The following table gives the preference schedule for the election. So here is our preference schedule for our example. First thing that we want to do is to know how many ballots were counted in this election. Well, remember that this number at the top of the column tells us how many voters ranked the candidates this way. This tells me how many ranked them in this order. This tells me how many ranked them in this order, and so forth and so on. So if I want to know the total number of voters, I simply need to find the total number of ballots, and I can do that by adding together all of these numbers across the top. So in this case, 8 plus 3 plus 8 plus 9 plus 2, or 30 ballots were counted in the election, and therefore 30 people voted in the election. The next thing we want to know is which candidate has the most first place votes. So to do that, we come up here to first place, and we look to see that A has 8 plus 3, or 11 total first place votes. B has 8 first place votes, C has 9, and D has 2. So A has the most first place votes with a total of 11. Which candidate has the most last place votes? Well, in that case, we're going to come down here to last place, and we're going to count up the votes. So A has 9, B has 2, C has 11, and D has 8. So C has the most with 11 last place votes. And if the choice was just between the barber and the doctor, who would get more votes? Well, this is where our transitive property is going to come into play, because we're going to look at each column and we're going to decide if the election was only between B and D, which candidate would win each column. Well, in this case, you can see B is ranked above D, so B would get the 8 votes in this column. In this column, D is ranked above B, so D gets these 3. B is ranked above D here, so B gets this 8. B is ranked above D in this column, so they get 9, and D is ranked above B, so D gets these 2 votes. So you can see that overall, barber is favored over the doctor in 25 of the 30 ballots. And therefore, if the choice was just between the barber and the doctor would win.